Okay, 1, 2 sets of real numbers. The vocabulary that we're going to talk about today is real numbers. Well, real numbers are both rational or they are irrational. So if you look at this graphic organizer, all of these are real numbers. Now, inside real numbers, you have a whole number, integer, rational, and a real. So let's start with the innermost. If I'm a whole number 0, I'm also an integer, rational, real. 3 is a whole, integer, rational, and real. Now look at square root of 4. Remember, square root of 4 simplifies to 2. And 2 is a whole number, integer, rational, and real. Same thing with 1. It's a whole number, integer, rational, real. This negative 1, though, is not a whole number, so it can't go backwards, but it is an integer, a rational, and a real. Okay, and negative 2 is an integer, rational, and real, and negative 3 is an integer, rational, and real. 27/4 is written in the fraction format, but it could also be written as a decimal. It's rational and real. 4 and 5/10 is a rational and real. A repeating 3 is a rational and real. And negative 6/7 is a rational and real. So let's talk about irrational. Irrational numbers cannot be written as a fraction. So irrational can't make a fraction. So with the square root of 17, it's just an irrational number. Negative square root of 11 is just irrational. Square root of 2 is irrational. And pi is irrational. Alright, so let's take a look at some questions. The square root of 5. Well, if you take the square root of 5, it cannot be written as a fraction. It's not a perfect square. So we classify it as irrational and a real. Negative 17 and 84/100. This is a terminating decimal, and so it can be written as a fraction, which makes it rational and real. Square root of 81 divided by 9. Well, the square root of 81 is 9. 9 divided by 9 is 1. This can be classified as whole, integer, rational, real. Alright, so your turn. I want you to try number 1 and number 2. Alright, a baseball pitcher has pitched 12 2/3 innings. You can actually turn this into an improper fraction. 12 times 3 is 36, plus 2 is 38/3. Since it can be written as a fraction format, we can classify it as rational, and we can also classify it real. The length of a side of a square that has an area of 10. So if we're talking about a square, all the sides are equal and the area is 10. The formula for area of a square is base times height. And so if we're looking for a number, two identical numbers that would get me 10, it would be something like this. You take the square root of both sides, and you get x equals the square root of 10. Now, the square root of 10 cannot be expressed as a fraction, so it is irrational, and it is real. Okay, flip it over to the back side. All irrational numbers are real numbers. Well, if you remember our graphic organizer, so inside of our graphic organizer, we have the real And inside the real, we have the rational and we have the irrational. And if we want to be even more specific, we have the whole and then we have the integer. I'll just abbreviate it, int. Alright, so all irrational numbers are real numbers. That's true. Every irrational number is a part of the real number system. So that is true. Every irrational number is included in the set of real numbers. Irrational numbers are a subset of real numbers. Alright, no rational numbers are whole numbers. Okay, so they're saying these whole numbers cannot be rational numbers. Well, that's false. Because, for example, if I have something like this, 5 can be 5 over 1, which is a whole number, it's an integer, it's a rational, and it's a real. So a whole number can be written as a fraction with a denominator 1, so every whole number is included in the set of rational numbers. Whole numbers are subset of rational numbers. Tell whether the given statement is true or false. Explain your choice. All rational numbers are integers. Well, rational numbers cannot go backwards to integers. So that is a false statement. It's actually written backwards. All integers are rational numbers. So it's written backwards. Okay, number 4. Some irrational numbers are integer. Well, this subset's not even in the subset with integers, so false again. Integers are rational numbers, so they're not irrational. Integers are rational numbers. All right. Let's take a look at the last example. Identify the set of numbers that best describes each situation. Explain your choice. The number of people wearing glasses in a room. So we're talking about people. People are always expressed as whole numbers. So I would say the set of whole numbers best describes this situation. The number of people wearing glasses may be 0, 1, 2, 3, 4, and so on. Okay, example B. The circumference of a flying disc has a diameter of 8, 9, 10, 11, or 14. So if we're talking about circumference, we're having to multiply by pi. And pi is irrational. So we're going to say the set of irrational numbers best describes the situation. Each circumference would be a product of pi and the diameter, and any multiple of pi is irrational. Alright, the last two, try by yourself. Identify the set of numbers that best describes the situation. Explain your choice. The amount of water in a glass as it evaporates. So this would be real numbers. It's going to be any number greater than 0. However, I can't be any more specific than real numbers because I can't guarantee that it would be irrational or rational. It just has to be greater than 0. Okay, the last one. The number of seconds remaining when a song is playing, displayed as a negative number. Well, this is also going to be a real number. And same thing here. I can't be specific whether it's rational or irrational. It just has to be any number less than 0. Any number less than 0.